Hey guys, another chapter 8 section 5 video today. So topic is 8.5, assuming you're using the book we are in class, and you can date your notes today, and we are going to talk about how can I find the intercepts. So that is our essential question today. How can I find the intercepts? And honestly, we've done intercepts before. We learned this back when we were learning lines. So intercepts are not something new. There are two types of intercepts I am talking about today. So I'm going to draw a little arrow up here. I am talking about x-intercepts, intercepts, and I am talking about y-intercepts. And like I said, we learned about these originally when we were doing lines. That's kind of how we got started, actually. So for our notes, before we actually do a full problem, what I'm going to do is I'm going to be drawing a xy axis. Gosh, I wish I had my ruler handy. Make these a little straighter. And I'm not actually going to put any numbers on my graph. My plan is this. I'm just going to make kind of a random line. So I'm going to make up a fake line here, something like this. And I'm doing this because I just want to highlight where those intercepts are happening. Where's the x and where's the y intercept? So if you look at our graph, this is our x-axis. And if that's our x-axis, then our x-intercept is happening right here at wherever that point is, right at that location. So this spot is our x-intercept. I'll label that. And my y-intercept is going to be happening on the y-axis, which is this one. So my y-intercept is happening at this location right here. Y-intercept. And what do we know about those locations? Well, I didn't put any numbers on my graph, so the location of that number kind of depends. But I do know that at this y-intercept, what is the x value? The x is equal to 0. It's right there. So the y-intercept is happening at some 0, some number, depending on what value I have on the y-axis. And the x-intercept's kind of the opposite. What I know is that the y equals 0 location. So the x-intercept's happening at some number, 0. So every time we do the x-intercept, what we really remember is that we're finding the x point, but it's always at y equals 0. And when we find the y-intercept, it's always at x equals 0 and some y number. Now that's going to help me out because we are going to transfer that knowledge and that understanding to the more recent things we've been working on, which is quadratics. Quadratics has been our next step. So next to this graph, I'm going to draw another xy axis, something like this, and this. Same thing, label it x and y, get my graph all set up. So now on my graph, what I'm going to do is not draw a random line. I'm going to be drawing more like a random parabola. So maybe something like this. There's my parabola. I really did kind of draw it at random here, but this is what I want to highlight. Where are the x and the y intercepts? Well, I see the y-intercept. It's right here on the y-axis, right at that location. So there's my y-intercept, absolutely. Where is my x-intercept? I see 2. The x-axis here has 2 locations. So I see one that's here. That looks like an x-intercept. But I also see one that is over here, x-intercept. So we've got 2 locations that we have our x-intercepts at, 2 possible. And did you know there's another name for x-intercepts? There's actually a second word that a lot of teachers like to use. They call it the root of the graph, the root. So you might have a high school math teacher say, where are the roots? And what they mean is where's the x-intercepts? Some people also honestly call it the zero. I don't know why in math we make things so confusing. We give you 3 different names for the exact same thing. So you might have a teacher that says, okay guys, we're going to find the x-intercepts today. You might have a teacher that says, okay, we're going to find the roots. And you might have a teacher that says, okay, can you find the zeros for me? All 3 of those words mean the same exact thing though. And all it means is where on the x-axis does the graph cross. So today, I want to find roots. That's what we're going to work on. So we're going to try some example problems now. And we'll start at the top up here. Let's call this example 1. So example 1. And we're going to look at a function. We could call it f of x. I think I'm going to just call it y equals, though. I'm going to call it y equals x squared minus 2x minus 3. And I want to know, where are the roots? Where are the x-intercepts? And the y-intercept, to be honest. So I could just graph it right away to try to figure that out. I could plot points, connect it together, and take a look at it. But instead, I want to go for kind of an algebra strategy here. So underneath, I'm going to say I want to find the x-intercepts and figure out where those are. I'm going to leave a blank spot for that. I want to find the y-intercept. And if I decide I'm going to fully graph it, what's one more thing that would help me really graph this nicely? The vertex. Honestly, if I can find those three things, the x, the y, and the vertex, I'm going to know really well what the picture of this graph is going to look like. So let's do a little math here and kind of think this through a little bit. So remember, if you look back at your notes, the x-intercepts happen when the y is equal to 0. So to find these x-intercepts, our y value needs to equal 0. So down below is where I have space to work. So down below, I'm going to take the equation y equals x squared minus 2x minus 3. And what I'm going to do is I'm going to change the y to a 0. So I'm going to have 0 equals x squared minus 2x minus 3. Aha, this is exactly what we've been practicing in earlier videos. We know how to solve these. We know to solve a quadratic, set it equal to 0, and factor it, use our rectangle diamond process to make this simpler. We call that the zero product property. We're going to use that zero product property. So over here, I'm going to do a quick rectangle diamond. Gosh, we've done a million of these, so they're kind of fast now. X squared goes in the corner, minus 3 goes across from it. Times that together, that's negative 3x squared. Minus 2x goes in the bottom. And we got to find something that multiplies to 3 but gives us a negative 2. So the only thing I can think of is 3 times 1. But I'll have to be a negative 3 times 1 to give me a negative 3x squared and a negative 2x when I add it. So negative 3x and 1x go in the corners. X times x is x squared. X times minus 3 is negative 3x. And negative 3 times 1 is negative 3. So cool, we got it. We got x minus 3 and we got x plus 1. And that was really quick because we've done so many of these, but hopefully you followed along with me. So I split this problem up now. I'm going to do a quick split. I'm going to take x minus 3 and set it equal to 0. And I'm going to take x plus 1 and set it equal to 0. And both of these will be really fast for me to solve. I'll add the 3 over and get x equals 3. I'll subtract the 1 over and get x equals negative 1. And we just got 2 answers for x, which makes total sense because when we were talking about graphing parabolas earlier, we talked about how there are 2 roots, 2 x-intercepts typically. So here they are. They're at 3 and negative 1. Now that means up here on my x-intercept line, one of the roots happens at 3, 0, and the other one happens at negative 1, 0. That's what we just discovered. So that's helpful information. All right, how about this? Before we do the next step, I'm going to grab a ruler, and I'm actually going to graph these. I'm going to put a little graph over here of what these would look like. So using the little bit of space that I have here, there's my y-axis. We'll put my x-axis here. Make sure I have room for this. Oh, I mean, why not get things started? If I set up the beginning of my graph, I'm actually going to need some scale numbers too. I'm going to put 3, 0 as one of my roots. So here's 3, 1, 2, 3. Here's 3, 0. Here's my x-intercept at 3. And my other one's at negative 1, 0. So here's negative 1 right here. Be right there. So at least I have a beginning idea of what this graph looks like. It crosses through those 2 points. All right. Well, that helps me out. Now let's kind of move on to our y-intercepts, and then we'll come back to this graph and add more detail. So remember what we do for the y-intercept. The y-intercept is when the x is equal to 0. It's kind of opposite thinking. So this is going to be a little bit quicker. It means we're going to put zeros in for the x's. I can practically do that in my head, but I'm still going to show my work over here. So I'm going to take my y equals x squared minus 2x minus 3 equation and put zeros in for my x's. So I have y equals 0 squared minus 2 times 0 minus 3. Well, 0 squared is 0. 2 times 0 is 0. So really I just have a minus 3 that I end up getting as my y-intercept. So that helps me out. That means up here my y-intercept is happening at 0, comma, negative 3. All right, that's really helpful. So 0, negative 3 would be 1, 2, 3. That'd be like right here. There's my y-intercept. So we're slowly piecing this graph together. I still have one more thing. I still need to find my vertex, but then I'm going to be set. So I'm going to go down below, and now I'm going to do my vertex work. You know, I don't really like my organization today. It doesn't look super nice. So what I'm going to do is kind of clean this up for a moment. So all the work that I did here in this section, including my rectangle diamond, all of this was my x-intercept stuff that I was working on. So I'm going to write x-intercept just so people can read it. And then this little section down here, this little part right here in the corner, that was all my y-intercept stuff. There we go. And a little nicer at least. I guess with that being said, down in the very bottom, this is where I'm going to do my vertex work. All right, so how do we do a vertex problem? Well, we have a formula. We've memorized it. It's x equals negative b over 2a. And we've seen this before, so we need to know what does a equal, what does b equal, and what does c equal to do this problem. Actually, we really only need a and b, but here's the equation. X squared minus 2x minus 3. So here's a. A would just be 1. Here's b. It's a negative 2. And c is a negative 3. And we're going to change negative b over 2a to negative blank over 2 times blank. And we're going to put for b a negative 2 in there, and for a 1 in there, and do some quick math. Now negative 2 becomes a positive 2. 2 times 1 is 2. 2 divided by 2 equals 1. So we just figured out that our vertex is at x equals 1. So I'm going to clean that up underneath and write x equals 1. But here's the deal. Think about what that means on the graph. So I'm going to go up to the graph. Here's x equals 1, where the vertex is supposed to be. What does that mean? Well, that means on my graph, if I make a dotted line, my symmetry goes right between that point, which is great. But I still actually don't know like how far down to go on the dotted line. Like where do I place my actual vertex point? So I'm not completely done with this problem. Yeah, it's happening at 1, so my vertex is at x equals 1, but comma what? What's the y value? So I have one more thing I want to do. I want to find the y value. I want to know where does this happen. So if I'm going to x equals 1, I'm going to do 1 squared, take away 2 times 1 minus 3 to figure this out. And again, I'm trying to organize my work a little bit, so I'm going to go back down here and say, okay, let's do that real small, maybe over in the corner here. So it's going to be y equals 1 squared minus 2 times 1 minus 3. That means y is going to equal 1 squared is 1, minus 2 times 1 is 2, minus 3. 1, take away 2 is a negative 1, take away 3 is a negative 4. So y equals negative 4. Write that real small down there in the corner. Hopefully you can see that in the video. And we now know where our vertex is. It's at y equals negative 4. So that means the last missing piece on my line here is a negative 4. That means at 1, negative 4, 1, 2, 3, 4, we've got our vertex. And that's enough information for me. Like I could do more, but I really don't need to. I can piece this graph together now. I see my parabola. I see it going something like this. And then back up. And I also know that it will extend and continue upwards, pointing in the upwards direction. And there it is. So I'm going to label this. This is my vertex. Get a label on there. I'm going to label my y-intercept, which is right here at negative 3. So I'm going to write y-intercept right there. I'm going to label my x-intercepts. There's 2 of them. X-intercept, there's a root right there. I'm going to label my other one, right there. And I've got a completed graph. Now you guys, this is pretty much the whole picture. So what we've done here is we've found all the details, the characteristics that we really care about in parabolas. We found the line of symmetry. We found the vertex, which is the lowest or the highest point. We found the roots, the x-intercepts, and the y-intercept, and that's it. That's the key characteristics that bring this graph together. And I feel pretty good about it, actually. So this is what I want you guys to be able to do. I want you to be able to take any quadratic equation and find these three different things. Find those x-intercepts, find those y-intercepts, find that vertex. Eventually, this is going to be the easier way of graphing versus just making a table. Sometimes making a table is not the easiest strategy. So that's kind of why we're working on this. We're trying to aim for that. All right, so let's do this. Let's try one more problem, but this time it'll be your you try problem. And what I want you to do is I want you to find the x and y intercepts for this equation. Y equals x squared minus 9. And today for the video, you only have to find the x and y intercepts. So I'm not requiring you to graph it and find the vertex. I'm going to cut you loose on that part. But try, hit your pause button on your device right now and see if you're just able to find the x and y intercepts algebraically. Go ahead and try. All right, are you done? Are you ready to check your answer? Because I'm going to go through these pretty quickly, I hope. So we're going to do the x-intercepts here, and I'm going to do the y-intercepts over here. And x-intercepts, we know we have to put in 0 for the y. So it's going to be 0 equals x squared minus 9, which is a special case. Technically, that's 0 equals x squared plus 0x minus 9. It's one of those special cases. And if I do my rectangle diamond, we'll make this way easier. So let's see. Over here, I'll do a quick little, down here, a little rectangle diamond with this special case. X squared goes in the corner. Minus 9 goes across from it. You probably already did all this. Minus 9x squared goes in the top. 0x goes in the bottom. I guess I'm going to have to probably do 3 times 3. 3x times negative 3x gives me a nice 0. And 3 times 3 is 9. So I get 3x and negative 3x. And then if I go around my rectangle, x times x times 3, 3 times negative 3. So fast. Okay, so we get x plus 3, and we get x minus 3. And when we split that, x plus 3 is going to equal 0, x minus 3 is going to equal 0. We're going to solve both of those, subtract the 3 over, add the 3 over, and you see we get x equals negative 3, and we get x equals positive 3. And we got our intercepts. All right, so at negative 3 and positive 3, there would be 2 points on the x-axis if I was graphing. The y-intercept, way speedier. We're going to take the y equals x squared minus 9, and we're going to put 0 in there, and do 0 squared minus 9. Well, that's easy. 0 squared is 0, so we just get minus 9. So on my graph, I'm going to go to 0, negative 9. I'm going to go way down to negative 9, put my vertex, or excuse me, my y-intercept. And then I'll have my 2 key features. The only thing left is to double check what the vertex is. But that's it. And if I had a question on a test like this, I've got a level 3 right now. I've proficiently answered the question. I've pretty much organized my work and showed clear answers. The graphing it is the next step up. So graphing it is what gets you that level 4. It's putting the whole puzzle together. Now, before this video completely ends, I have one more thing I want to do with you guys, and I have a few questions I want to ask you. So first off, I want you to do a little thinking here for a moment. Is it possible, can you have a parabola that has 0 x-intercepts, no x-intercepts at all? In your notebook, see if you could draw an example. Can you think of an example of a parabola that has no x-intercepts? Is that possible, yes or no? You can pause your device and think about it for a moment. Well, I have my answer in my head. Do you have an answer? Think about it. What if your parabola looked like this? Had a vertex here. Are there any x-intercepts? I don't think so. So yeah, it's possible to have no x-intercepts. What if it was an upside down parabola going this direction? And the vertex was low. No x-intercepts. So can you have a parabola with no x-intercepts? Yes, totally possible. Absolutely. So how about this? If we know it's possible not to have any x-intercepts, my next question to you is, can you have a parabola with no y-intercepts? Think about it. Can you have no y-intercepts? Draw an example of a picture with no y-intercepts. This one's trickier. Think about it. No matter where you draw your parabola, even if you draw it like really skinny like this, what's this parabola slowly doing? It's slowly widening out, right? It's going to widen out farther and farther and farther. So as it widens out, eventually, isn't it going to widen out and touch the y-axis? I mean, even if my parabola was way out here somewhere like this, I mean, way off the graph, it's going to widen out, widen out, widen out. Isn't it eventually just going to get to that y-axis? No matter where you place it, it's spreading itself out. Now, if you tried to argue, well, what if the parabola does this? Well, that's not a parabola. In fact, vertical line test says that fails the vertical line test. That does not count as a parabola example. Parabolas only point up or down. So no matter what, up or down, as it widens, it's got to touch the y-axis. So can you have a parabola with no y-intercepts? No, that's not even possible. Not possible. Okay, so last one, and then this will be the end of our video today. Is it possible to have only one root? Only one x-intercept? Is that a possibility, or does there always have to be 2 or 0? Think about that. Only one root. So I'm saying it can only touch the x-axis once, not twice. Well, what if it was like this? How many roots does it have? Only one. It's the vertex. It happens to be the vertex. So yeah, it is the vertex, but it's also the root. So is it possible to have only one x-intercept? Absolutely, yes. Maybe it's a little more rare and not going to happen all the time. Most of the time we end up with 2 roots, 2 x-intercepts, but it's possible if the vertex is there. Or what if it was like this? What if it's the upside down version of that? Only one root, just happens to be the vertex. So totally possible. All right, guys, that wraps up this video, and I hope you kind of followed along pretty well. What I really hope you can do is at this point, you should be comfortable with this process we did in example 1. You should be able to find these 3 characteristics using algebra, and you should be able to place them on the graph. So if you're struggling with that, please get help or watch further videos. Thanks, guys. Have a good day. Bye.